get trig functions of any angle. Okay, so we've already covered trig functions of special right triangles, right? And then we learned all 6 trig functions. We learned your 3 reciprocal functions. Now we're going to look at, what if I just throw at you, like, find the cosine of 12 degrees. And you don't want to go straight to your calculator. That's the goal. The goal is to be able to do this without a calculator. Then that's what we're going to cover how to do that. So first, let's start by looking at this right here. Angles, rotations, and degree measures. An angle is a familiar figure in the world. In trig, we often think of an angle as a rotation. Okay. I need you to graduate from the geometry concept of an angle, where it's just the measure from one side of a triangle to another. I now want you to think of it as like a verb, actually rotating, okay? And the reason for that is because now we're getting into positive or negative angles, which means now you're rotating in one direction, or if it's negative, you're rotating in the other direction, and that matters. Look at these 3 examples right here. We have two vocab words. If you have a highlighter, it would be helpful. The first vocab word is initial side. The second vocab word is terminal side. Now let me explain what that means. Every single one of you is familiar with the 4 quadrants, right? Okay. When I say that we're talking about an angle, the initial side, if something initiates, that means the starting point, right? Remember, they used words to help you remember what it means. So the initial side you need to think of as the positive x-axis. That's where every single angle rotation initiates from, hence the name. So it's just landing, it's anchored there. All right? And then the other vocab word called terminal side means the actual part that is rotating, right? I know y'all love the demonstrations. The actual part that's rotating, wherever it stops rotating and terminates its rotation, is called the terminal side. Okay? So if I say, draw an angle with the terminal side landing in quadrant 3, that would mean that you just drew it and it's going to land down in quadrant 3, but you still got your initial side over here, your anchor, right? Of course, the vertex is always at the origin. Now, here's the new part right here. Okay? Let's draw some information to help. This purple example here, got your initial side, it's opening up, it's landing here, your terminal side. This is a positive angle rotation, positive. Notice here, you have your initial side, but instead of opening up, it's opening down. That's because this is a negative angle rotation. So the difference is this one went this direction, and this one went in this direction. Now we need to tie those words that you already know. You've got clockwise and counterclockwise. You've got to go back to an analog clock. If your generations, maybe not so much juniors and seniors, especially like my sophomores and freshmen, y'all grew up on digital clocks, so you really don't understand the whole concept of the arms rotating. An analog clock is like what I have right here. You have a big arm, small arm. The analog clock starts at high noon, right? And then it rotates in the direction of the numbers that it's counting. So if it's rotating to the right, when I say to the right, I'm thinking high noon and then going to the right, then that's called clockwise. If it's rotating to the left, that's called counterclockwise. how are you going to remember, because it's a little backwards, right? A positive angle is actually rotating counterclockwise, and a negative angle is rotating clockwise. So how are you going to remember that? Because if you mess that up, you get the problem wrong. I want you to think of how to name quadrants. Think of how you name quadrants. So always start with quadrant 1, which is over here in the top right, right? So this is quadrant 1. And then you go counterclockwise, right? So this is quadrant 2, 3, 4. Now you might think, why am I saying think of the way you name quadrants? Look at this. I don't like that. That's crooked. I want you to think of the coordinate plane. What does the word coordinate start with? C. How do you draw a C? Like this. Right? You with me? Okay, so in the direction that you draw a C is the positive numbers that you label the quadrants, and that is a positive rotation because I labeled it with positive numbers. So if you'll tie together the way you label the quadrants with positive numbers, went what direction? It went counterclockwise. And that's how I remember, okay, I label counterclockwise with positive numbers, so a positive angle measure goes counterclockwise. That's how I remember it. And then this is just the other one. I also just remember they're backwards, right? So if you look at this right here, what quadrant is this one in? This is 4, and this would be 3. So let's make a note. Positive angles actually go counterclockwise. This is the abbreviation you're going to see me write a lot. And negative angles go clockwise. That's the first big takeaway that you're going to have to commit to memory, or trig is challenging. Know these vocab words and know what direction a positive angle goes and a negative angle goes. Look at these 4 right here. These 4. You see them? Kind of hard to see probably on your paper, so I'll use a highlighter. This one is here. This one is the whole thing. This one is this square. And then this one is right here. There's a vocab word for these. They are all called quadrantal angles. Here's why. Do you notice how the terminal side lands on an axis on all 4? It's that perfect square, you know what I mean? That's why it's called a quadrantal angle, because it's actually splitting the 2 quadrants. It's not hovering in between. It's almost awkward because it's landing on the axis, okay? We'll pick back up on this tomorrow.